So this is lesson number 63 in Algebra 2, addition of vectors, and let's get started here with a little bit of a review. From page 234, we're introduced to vectors, and if you remember, when you're given an xy axis, and given that xy axis, let's say that we are at this point right there. And if you remember, we want to know how long that is, and also how many degrees that is. Alright, so the way we write that in polar form, or in vector form, is 20 at 20 degrees. Now if you remember, when we were trying to convert this to rectangular form, we have to find a point right there, an x, y. So we need to find out how far we go this way and how far we go that way. Alright, so in order to do that, we use two formulas. In order to find this part, we took, so our x value equals the hypotenuse times the cosine of theta, which theta is the unknown. It's the x value. It's what we don't know. When we don't know an angle, we call it theta. So 20 cosine of 20 degrees. And to find y, we had h sine of theta, so that would be 20 sine of 20 degrees. And what that does then is it converts it to rectangular form. So that would give us that point up there that we're looking for, this point right here. So when we do the math and we find out what 20 cosine of 20 is, that ends up being 18.8, and our 20 sine of 20 is 6.8. So then remember, we wrote this as 18.8 r plus 6.8 u. Okay, so that's what it is in rectangular form. Alright, so what we're going to do here is the addition of vectors. And when we add vectors, they're going to give it to us in this format. So we may want to add that to this here, which is the first example in the book. We want to add those two. In order to add those, we have to switch both of them to rectangular form, which we just did right here, and then add them together. So let's go ahead and erase all this and look at this first example. And I'm going to get rid of my, no, I'm just going to move my graph here. Alright, so we have flying arrow left the village and traveled 20 miles on a heading of 20 degrees. Okay. Then he turned and he traveled 40 miles at a heading of 210 degrees. How far from the village did he end up? Alright, so what we do with that is we need to add those two vectors. Now we just found out that this vector from the one I just did was 18.8r plus 6.8u. Alright, this one is going to be, and I'm just going to write it on here because you should be able to figure that out using the stuff we just went over, changing it to rectangular. So now as far as adding vectors, this is the new stuff. We add the r's and we add the u's. So when we do that, we've got a positive 18 minus a 34, so we end up with negative 16r. And then when we add those, we get a negative 13.2u. And that ends up being the answer we want. So when we're talking about flying arrow, or whatever this guy's name is, he ends up at minus 16 down 13. He ends up somewhere over here. Alright, so according to the instructions, he went 20 degrees, a distance of 20 that way, and then he went 210 degrees, so he went another direction and ended up here. Okay, so how far was he from the village? Well, we're not really concerned at this point in how far he was, like this way. We're concerned about this way and then down. That's all they want you to do with that. Alright, so we go to example number 2, bottom of the page. Get my graph out of the way here again. And they're asking us to add 30 at 55 degrees to 10 at 170 degrees. Alright, so we've got two different things, and really, you know, they're saying here, think of these trips as 30 miles and 10 miles and the distance given and all that. Doesn't really matter. We're just interested in adding those. So let's go ahead and do that. This one right here, my x value is going to be, again, h cosine of theta, which in this case would be 30 cosine of 55, which equals 17.2. And then my y value is going to be h sine of theta, which is going to be 30 sine of 55, which is going to be 24.6-ish. Okay? So converting that to rectangular would be 17.2r plus 24.6u. That would be the conversion into rectangular. Alright, so let's take this one here and convert that. My x is going to be h cosine of 170. And then our y value will be 10 sine of 170. Okay, so 10 cosine of 170 is going to be 9.84. In fact, that's going to be a negative. And 10 sine of 170 will be 1.73. Alright, so let's go ahead and write that as negative 9.84r plus 1.73u. And then we add those up. We just add the numbers, 17.2 minus 9.8, and we get 7.36-ish r plus 26.3u, and that ends up being the answer. And that's all there is to add those. Okay, so there's our answer. Now let's say that we wanted to convert our answer back to polar form. We've got a triangle, and this is 7.36 because we went r, and then 26.3 up. And then if we want to find that, we use Pythagorean. So we write 7.36 squared plus 26.3 squared and do the whole Pythagorean and get 27.32. Then we have to find this angle right here. Well, that angle we can find using tangent. So tangent of theta is going to equal the opposite over the adjacent. And that is, this here would be tangent theta equals 3.58-ish. And then, in order to find that angle, let me put that over here, we take the arctan, so tangent negative 1 of 3.58, and that would give me an angle of 74-ish degrees. So that would be converting it to polar. So if you want to do that, I don't think they're going to ask you to do that, but If they do, that's pretty much all there is to it. You just remember, you use the tangent, and then you use the arctan to get the degree. And the number here, the hypotenuse, is just using Pythagorean. Okay, so that's it for lesson 63.